Good afternoon, everyone. Thank you very much for joining us this afternoon for our live webcast in partnership with IBM. In today's session, we will be focusing on DevOps continuous testing, integration testing, and service virtualization. We will be presenting what DevOps continuous testing is, performance testing, and service virtualization. I am proud to be joined today by my colleague and partner. Shug is our CEO of Test House, and he heads up our strategic business alignment. Nick Bortolowski heads up the worldwide development team for automated testing and service virtualization for IBM. Nick has worked in the integration testing service virtualization space for 5 years and joined IBM as part of its acquisition of Green Hat. He has over 20 years' experience in the IT industry, much of it spent running development testing. I quickly go through the agenda. So the agenda and presentation for today will be 30 to 40 minutes presentation plus Q&A at the very end. So before I pass you over to my colleague Shug, please feel free again to type in your questions on your Q&A pod now or during the presentation. We will always try and reply to all or most of your questions if time permits. A full screen is also available at the top of your screen if you need us. So without further delay, I now pass you over to my colleague, Shug.
Hi, good afternoon, everyone. My name is Shug Sahadavan. I'm from Test House, and I'm just going to briefly talk a little bit about Test House, and then the challenges about testing in general, and also the challenges within environment management. And then I'll leave that as a challenge for Nick to answer with a solution. So a quick few words about Test House. We've been around for about 15 years or so, started in 2000, and purely focused on software testing services, so the quality assurance and the quality control piece. And we're headquartered in London, currently located in the Docklands. And we have full service centers in India and in Dubai. And we have sales offices in the U.S., in California, and in Saudi Arabia. In order to do our service, we rely on testing tools. And, we like to believe that we are partnering with industrial strength and leading providers of testing tools. And one of our partners is IBM. And hopefully we will show you the strength of the IBM tool, especially regarding service virtualization today. Our services, just a quick 1 minute overview of our services, is based around QA and QC, so quality management, strategic guidance. So people believe that quality or testing is just purely restricted to just the testers. It is a holistic. You have to have a full company buy-in to have proper quality. So if you don't have the buy-in of the CIO for quality, then you're not really having quality at the root ends. We also provide managed testing services where we are responsible for the QA of the quality of your system and systems. And we also provide some training specifically around the tools that we work with. And obviously we do the basic functional testing, including the automation of functional testing and things like compatibility testing that fall into that. Non-functional testing predominantly based around the performance and scalability side, but we also do things like disaster recovery testing and operational readiness testing. Right, in order to keep ourselves abreast of what's happening in technology, and we need to do that as a testing consultancy, we need to know what's happening in the marketplace, where the future is going. We try to keep ourselves abreast of by reading articles and making sure that we're working with the partners like IBM. And over the years, testing has changed, especially over the last 5 to 6 years. The role of the tester has changed. as well as the expectations of a tester has changed. The guys are doing more exploratory testing, more unit-level testing, and that before they used to do, the capture from what's in the requirements and try to write test cases and test scripts and execute those and produce the results. Now it's more agile, and we also got the operational side being coming into the dev area with DevOps. So it's changed in terms of the role and also the skill level as well. People of old could get away with just pure functional testing. Now you need to have a fairly good grasp on automation, the test environment, the data requirements, all those things. And so it's a changing world. So we've looking at that survey that was presented in the last slide. From that survey, we've got what the reality of for testers. There's 2 slides on that. The first one shows you that that testers are not really doing as much testing as they should or as they could. Most of the time, don't we just love the meetings? We spend an hour. I know friends of mine who come out of meetings and go to another meeting and spend all day doing meetings. I don't know what they do after that. But there are things like ad hoc requests, emails, all of those things they're spending time on, but not actually doing the work that they're supposed to do. And as you can see at the bottom there, 28% of testers are not testing 50% or more of the time, which is quite worrying, really. So what we need to do is to increase that percentage, from 50% and also from the 28% side. We also need to increase the quality of testing by making sure the testers are finding higher level defects rather than spending time finding spelling mistakes or very minor errors. We just need to focus them on to do finding higher level defects. And also the interest of testers, they want to be doing more automated tests. And if you look at that, is that they want to create automated tests, but also want to execute them and also maintaining them as well. So a lot of focus on test automation, and obviously they want to spend as less time as possible in setting up labs. Well, here we are talking about setting up test environments. I don't mean just labs as in medical side, but I mean actual test environments where we have, in some cases, very simple client-server type environment which you can set up, any normal person can do, to really increasing in complexity to include data feeds coming in, message-oriented middleware, enterprise applications, SAP, Oracle ERP, all those sort of solutions. Trying to set up a test environment to do by a tester is very, very difficult, practically impossible. Not practical, yes, practically impossible to do unless you have specific experienced configuration people who can actually set up those environments for you. So, but the time is spent by testers in setting up those environments, and they constantly get it wrong. And we spend quite a lot of time trying to find bugs in the application, but in the end up finding bugs in the environment configuration. So we want to try to improve this the way that we run the operations of testing. So I'll go on to the next slide. So if you can have a look at what's happened in the past to what's currently happening in the marketplace, and dare I say the word, if you look at the 2 graphs, things have shifted to the left. And in order to gain competitive advantage, and it's all about that for the business today, organizations and customers are demanding teams release higher quality software faster. So it's all about change coming through at rapid pace. If you think about people like AOL or the large organizations where they're turning out large changes very, very quickly. And the competitive advantage comes if you can ensure that you're releasing software even faster. And development teams are becoming more and more agile. And going back to the first time, I spoke to a CIO recently who said that cost for him is not the issue, but the rapid change is, which is a pretty music to my ears, not because of a consultancy, but it was ever so challenging the last few years. Everything was about cut costs, but today it's seemingly more about how quickly you can release things faster. So that's the sort of challenge of the environment at the moment. So before I move on to Nick, I just gave you a quick, brief overview about TestHouse. And the challenges out there is faster delivery, therefore more testing. Testers spending more time not testing. Testers finding lower priority defects. Operations and dev test not connected, and hopefully that will come through to that. And Nick will now try and explain a solution based around service virtualization, helping to address not all of those, but at least some of those challenges that are in the marketplace at the moment. With that, I hand you over to Nick. And Nick, are you there?
Yes, thank you. Good afternoon, everyone. So as Shug said, I'm going to be talking about IBM's integration testing and service virtualization solutions and how they can address some of the challenges we've just presented. It's useful to kind of build up how they sit in the overall story. And I'm sure you'll have heard of DevOps. Certainly IBM has been talking about DevOps for some years. And the solutions I'm going to talk about really fit into this DevOps capability. I'm not going to spend too long on this. This isn't intended to be a pure DevOps presentation. But DevOps is really about balancing speed, cost, quality, risk, the usual things, and building a pipeline to accelerate software delivery. So it's all about a capability and a culture to allow an organization to get new features, new products, enhancements, new things to market very quickly, and to be able to take feedback and spin very quickly, make changes very quickly. So really to respond to the rapid rate of change that customers now expect. Part of that is certainly a culture. So an organization has to accept that it needs to do various things in order to make that work. Development, operations, test all need to work very closely together. I'm not really going to focus on that today. The other side is a capability. It's very good to say we want to be able to do this, but you need to have tools. You need to be able to have a pipeline. You need to be able to have techniques that allow you to do this, because it really means shrinking parts of the software development lifecycle that traditionally would take some time. And you can't really necessarily shrink them, because if you don't test, then what you put out won't be of quality. But you need to be able to start doing things in parallel and overlapping tasks that typically may well have taken place one after the other. But the goal is to get a series of tools, a series of capabilities in order to build a pipeline. That means someone can go from having a bright idea to getting it out to customers and getting feedback and making changes very quick and very continuously. Getting this wrong has serious consequences. These are some very high-profile examples. Clearly, not every software failure is quite as big as this, but there have been a number in the news over the last few years that have cost organizations significant amounts of money, and in some cases, the organization ceased to exist. And many of these came down to pushing through upgrades with insufficient testing, to having too many manual processes, to not having enough automation. But in the end, they came down to failures within the organization to really address the balance of risk versus the desire to release early and get some changes. So I'm not going to talk through these, but I'm sure you're all aware that getting this wrong has significant consequences. And as an important part of the process is testing. It's very easy to say we should test more, we should test better, but the reality is it's a pretty difficult environment to test in. As Shug said, development teams are more agile. The pace of change is very high. They're able to push out changes very quickly. There's been a lot of improvements in the last number of years around developer productivity. And certainly as we go into the mobile world, the big data world, the social world, we're able to push out changes to multiple platforms very quickly, and that's really hard for testing to keep up with. Products getting complicated. It's all about integration. It's about building services. It's about exposing what would have been back-end type capabilities down to mobile devices. And there's a significant amount of technology in place in order to do that, which makes test labs and test environments extremely complicated. And although it may not be all about cost, it's certainly true to say that you can't just throw people at this problem. It's not really sustainable, particularly as you're trying to get things out much more quickly. So we need a solution to address the speed at which people are developing things, the complexity of the environment, and the fact that this ceases to just be a people problem. The other challenge, and certainly this has been true traditionally, is that a lot of testing has been focused on the user interface. And that's fine, and clearly you need to test a user interface. But certainly it's becoming true that there's an awful lot of complexity kind of below the waterline. We have this metaphor of an iceberg. As I'm sure you're aware, the most of an iceberg's under the water. And that's true with systems. A lot of the complexity, a lot of the integration, a lot of the things that actually need to happen are important, are not exposed via the UI. We can do traditional UI testing once we have the UI available, but it can be very hard to validate that the integration is working properly at the UI level. And we need a different approach to testing, and that's where the idea of integration testing comes in, which is testing directly below the waterline, and I'll come on to that a little bit later. But it has several benefits, one of which is that we can test much earlier, because often these services exist and are available for testing long before the UI is. It also introduces the concept of service virtualization, where we can start to simulate parts of the environment to enable testing to happen much more quickly. But as I talk through, I'd like you to think about this idea of an iceberg and all the complexity that's underneath what's seen on the UI, and realise that we need to be able to test the under the water systems very quickly. Another term you will have heard being used in the industry in the last year or so is this idea of shifting left. And this is really a fairly simple concept, which is to say that traditionally in a software development lifecycle, the testing all happens at the end. All of the systems need to be ready, environments need to be ready, third-party services need to be ready, all the development teams need to have finished, and we put everything together and then we start testing. And yes, there will have been some unit testing at the beginning, but actually a large amount of the effort has to wait for the systems to be available. It'll go into a test environment, into a stage environment, and then we will start testing. And we may well start testing at the UI using UI automation. And that then becomes quite a long tail on the development cycle, because we will now spend several weeks testing. And if we find problems, as I'm sure you're all aware, there are all sorts of statistics showing how expensive it is to fix those problems. You have to go back round to development and effectively push everything through the process again. The idea of shifting left is to say, actually, we can start a lot of that testing much earlier. We can use techniques such as service virtualization, integration testing, to test components of the solution, test their SOA interfaces in different ways, virtualize, simulate things that aren't ready, and enable test teams to start doing meaningful testing on parts of the system long before everything's developed. Yes, you still have to do full end-to-end testing. There will still be performance testing, there'll still be staging testing, but importantly, that now becomes a much shorter part of the overall life cycle, because you will be finding far fewer defects. All of those silly defects, all those integration defects, all the things that just exist within a component will have been found much earlier in the development life cycle. And by the time we get to doing our end-to-end testing, we have significantly reduced the risk and will therefore reduce the amount of time we have to spend in that part of testing. So we've shifted our testing effort in order to reduce time to market. There are several types of testing. Developers should be doing unit testing, and there are all sorts of things that do need to get pushed back to development in order to make sure that testers aren't finding silly little errors. And open source really does very well in this area. This is not a space we particularly play in. There are a lot of frameworks, a lot of tools that developers can use directly. Equally, at the other end, UI automation is here to stay. You need to be able to test that your UI is working. You don't want to test your whole system through the UI. You're always going to be doing large-scale performance testing, and there needs to be a level of business acceptance testing and end-to-end testing. We want to push things back onto the developers. We want them to take responsibility for building unit tests, for having that integrated as part of their pipeline. We want to reduce the amount of time we spend on the final parts of the testing, and then we want to introduce these new concepts of integration testing, service virtualization, and something I'll come on to called early performance testing and continuous performance testing, in order to find as many faults as early as possible to shrink the latter parts of the development stages. The other thing to recognise, and I talked earlier that part of DevOps is a cultural change, is that actually the role of the tester is changing. And certainly in organisations that are doing this well, they're now finding there's this role, and I've called it here a DevOps tester. But it's really a tester who's aware of the ideas of continuous testing and isn't waiting for a complete system to be ready and then just getting involved in acceptance testing, UI testing, but is starting to bring in some of the technical knowledge from the existing technical roles, combining that with an understanding of what the business wants to do, what is acceptable, and really starting to use techniques such as service virtualization in order to test early. It starts to do continuous performance testing to understand differences between builds, and merges the best in the knowledge of the technical tester, knowledge from a traditional tester as to what are meaningful scenarios, takes those capabilities together, and produces someone who's familiar with the idea of continuous testing. And this is quite an important change. I'm going to talk about some tools and capabilities, but you need people who are able to use those tools and who can think about how to use those tools within the organisation. And then testers who can go back to developers and back to development and say, actually, we need you to change the way you're building systems so that we can use these ideas of continuous testing. We want smoke tests. We want automated builds. We want you to build things into the application that mean we can test much earlier. So the whole thing needs to be pushed back from the testers into developers so the organisation works together, and DevOps testers take a much more active role in the entire pipeline rather than just waiting for the software to be delivered at the end. I'm not going to dwell on this side, but this really kind of says what we're trying to do, which is trying to shrink that test cycle in the middle, the piece where we're really just doing purely testing. There are a whole load of enablers that enable us to shift some of that to the left. I'm going to go through some of that today. And there are actually enablers to shift testing to the right. Not really going to dwell on that now, but this is the idea of saying, actually, we won't test everything. I'm sure you're aware that people like Facebook and Netflix have this idea of a dark launch where a proportion of their users will get updated before everyone else. And they won't have finished testing. They're effectively testing in the wild because they need to scale. And they run the risk of upsetting some of their user base, but because they've only rolled it out to a few people, they're not going to upset everyone. A key ability, and why they do that, is the ability to roll back or have turnarounds done very quickly. So if you are prepared to accept the risk, and some organizations are, you will roll changes out very quickly. And if you start getting negative feedback, if you start looking at sentiment analysis and realize you've broken something, you need to be able to change that very quickly, and your operations side needs to be able to roll out changes. But we're focusing on shift left here, but there is also a shift right piece, which says actually we'll test in the wild, and we will allow a small part of our user base to do some of that testing, and we'll accept that there might be problems, but we'll be able to fix them very quickly. Okay, so that's some of the background. Now we're going to get down to talking about the product set and actually looking at what integration testing and service virtualization mean, and how testers actually use them. So there are two concepts here. The first one's automated integration testing. Increasingly, this has started to be called API testing. And I can see over the next year or so that name may change. I'm going to stick with integration testing now because API testing can seem a little bit technical and detailed. But either way, this is what it means. These days we'll have a system under test, and that system will probably be made up of a number of new things that we've developed. So there will be possibly some services hosted on an application server. There may be some changes to a back-end, maybe a mainframe. There could be an SAP system. There will be some software that is collaborating between individual machines, and it will be using service-type capabilities, so REST interfaces, web services, messages sent over MQ, HTTP requests, in order to deliver the capability of the overall system. Integration testing is really it's testing, but instead of testing at the UI and using the user interface to make things happen, we are going to inject messages directly into the system. So this might mean at a very simple level, making a web service call, making a call over an HTTP interface, maybe injecting a JMS message, calling a mainframe transaction, calling an SAP program directly, a whole range of technologies, but we are not using the user interface. We're using the published API in order to inject a message, and a message could be a piece of XML, could be a COBOL copybook, could be a proprietary format, but we've injected it into the system in order to make something happen. We could be checking a customer details, we could be doing a credit check, we could be creating a new insurance policy. But we've done it by injecting some content, and we've watched what happens. And typically what happens is a message comes back. And the test is really to see whether the message that comes back is what it should be. Does it contain the right data? Does it look correct? Has the system done the right thing? And at a very simple level, that's automated integration testing. Some of our bigger customers will have 100,000 plus tests. Some of the bigger banking customers have 100,000 plus tests in their regression suites that send in millions of messages and look at the responses to see if the systems are doing the right thing. Slightly more interestingly, we actually want to look inside the system. It's all very well known that it came back with the right message, but we really want to check that audit databases were written to, but as the messages flowed around the system, they contain the right data. And importantly, if we were passing on data to other systems, maybe third parties, that those also happened. So the overall test needs to look at data as it flows around the system and validate that the right messages are being sent at the right times, that they contain the right content, and possibly checking that things like the database contain the right audit records. And a single test can do all of these things and validate that everything happened correctly, and then scale that out to get more and more tests. And now we can press go in a tool. It sends all these messages in, validates everything happens, and it hasn't needed to do that through the user interface, which means the UI doesn't need to be ready, and we're not susceptible to the fragility of changes in the user interface. So that's integration testing. The other side of this is service virtualization. Now, if we assume a system under test exists, nothing exists in isolation these days. It will be working with other pre-existing systems. Some of those may be owned by the same organization. Some of those may be third-party calls. Increasingly, people are calling out to all sorts of systems. You'll have heard of the API economy, and people starting to build APIs that, for other people to use. So very few systems exist in isolation. And whether we're doing UI testing, performance testing, manual testing, API testing, we need that whole system to exist before we can start doing that testing. And that's a bit of a challenge because typically nothing is ever ready all at the same time. Development teams tend to be late. Third-party systems might be expensive. Third-party systems might not be ready yet. So as a tester, I can be thinking, well, I want to test my system under test. Maybe I want to do some performance testing, but actually I can't do it because it relies on a third-party system. Maybe we're doing a credit check, and that third-party system isn't available for whatever reason. Therefore, I can't do my testing because the overall system isn't there. We introduced the idea of a virtual service, and a virtual service is a simulation at the technical interface level that allows the tester to be in control of the data that's returned. So in this scenario here, the tester has built a virtual service that does what they want it to do, which is just enough for this test case. They've started it. The environment's been reconfigured so that as far as the system under test is concerned, it's still talking to the third-party credit check system, but actually the messages are never reaching that system because it doesn't exist yet. They're actually reaching the virtual service. It's looking at the data that's coming in, and responding in the way that the tester wants. So I can now start testing my system under test. I can build a virtual service that responds negatively, positively, responds with edge conditions in the return data, and I can now do my testing. So this is to say that, yes, I've got a system that exists, and in the top right here, I've got a mainframe, and it exists, and I can talk to it, but actually it's really hard for the tester to make it respond in the way that I want. It may be very difficult for them to force an error in a mainframe program. It might be difficult for them to set up data in the DB2 database on the mainframe that does just what they want. So in this case, again, a tester can say, okay, I won't talk to the real mainframe because that's not what I'm really trying to test. The thing I'm trying to test is the system that's talking to the mainframe. So I'll create a virtual service, and it will respond with an error. It's going to look to see that when I get a request for Nick Portelski's customer data, I'm going to return a particular error. And it might be very difficult to force that error in the real system, but the tester wants to check what happens in the very rare situation where that error is going to be returned. They can do this very quickly. They can start a virtual service, make it return an error, and as far as the system under test is concerned, it's still talking to the mainframe. But when it asks for Nick Portelski's data, an error comes back, and the tester can now test that scenario. So what this allows the tester to do is to start testing much earlier in the life cycle, because they don't need all the dependent systems to exist. They can build virtual services to represent those things that don't exist. And they can test much more effectively because they can start causing error conditions. They can put edge case data in, and they can do it in 10, 15 minutes rather than having to wait days and days for development teams that aren't under their control to make the changes. The other thing that we're seeing people do is this idea of continuous performance testing. And this really comes out of the idea of continuous regression testing. So for many years, developers have been building unit tests that will run, say, in a Java world, JUnits against a test build and see how it responds. The other thing we're starting to see people doing is this idea of low-intensity testing against builds. So as someone makes a change to an application, there might be side effects. And one of those side effects might be to have actually seriously degraded the performance. But if you don't notice that until you're doing your large-scale performance testing at the end, you're now in trouble. You've got a very expensive set of changes to make. What you really want to be doing is running some fairly basic performance tests every time you do a build. Continuously. And you're not necessarily looking for absolute numbers because you're probably not running it on the real hardware. But what you're looking for is trends. You want to know if suddenly some tests start taking 15% longer on this build than they did on the last build, because that's probably a bit of a warning. And someone should now go and look into that. And you may fail the whole build if the performance of a set of automated tests degrades more than 10% from the previous build. So you get people going to look at it. And in this way, you keep your overall performance relatively consistent. And when you get to the end and start doing your large-scale performance testing, it's much more likely to succeed because you haven't built up this debt of performance issues that you didn't notice as you went along. That's what we're really trying to do. In terms of our products, we have a continuous testing solution in the form of the Rational Test Workbench product. And this actually enables a whole range of tests. So there's UI testing, there's the integration testing I've talked about, there's performance testing, and we can do testing down on mobile devices. I'm not going to talk through all those, but Rational Test Workbench is our testing product, and it's also our design time environment for virtual services. We have a performance test server product which enables you to generate load and do performance testing. And we then have IBM's Rational Test Virtualization Server, which is the runtime engine for virtual services. So as a tester, I've built them and designed them, and now when I want to start using them, I publish them out to the server and I start running them. I'd like to finish up with something of a case study. This was a real customer in North America who's made extensive use of our virtualization and integration testing technology to really speed up the delivery of changes within their organization. So what they were doing was building some mobile apps, some browser apps, and some IVR, which is the automated telephone response systems where you type in numbers. Those systems needed to get all the way through to a systems of record, which was actually a mainframe, because that's where all the data and all the processing was. Some of that data needed to go to an external provider, But what they were doing was building new applications. They had a series of REST services that those applications were using to get data. Had some orchestration in the form of some enterprise SOAP services that would work out where data would come from, and then a systems of record, a mainframe. The mobile teams were able to deliver very quickly. The mainframe teams and the external providers were actually delivering much more slowly. Their changes took more time and they were a more controlled environment. So their problem was really they couldn't wait for everything to be ready to get this to market. So they did something quite interesting. They started by virtualizing and creating simulated REST services. And they actually did that because they wanted to sit down with the mobile development team and a set of business analysts and work through mocking up the client. And they actually developed the mobile application against virtualizations. Nothing else existed. They just used the tool to create some virtual services that would respond with some data and use that to allow the business analyst to understand the flow on the mobile device, which was quite unusual. Not everyone does that, but it was quite an effective use. They then moved on to proper development, and the front-end teams were developing their apps, and there was a team that was developing a set of REST services. Nothing else was ready. The SOAP services didn't exist. The mainframe guys were a long way off from having their development ready. So they virtualized all those SOAP services. They set up a whole lot of simulations, and that allowed the development teams and the test teams to start working. As pieces of the mobile app were ready, test teams could start using them. They were using the real UI. They were testing the flow. They could change the virtualizations, the virtual services, to respond with all sorts of data. So they could start testing with real data, seeing what happened when certain types of data came back. Could the mobile device handle it? And the developers of the REST services could also enable them to start doing some early testing. As the SOAP services came on stream, they moved away from UI testing and now built a set of automated integration tests. So they were using rational integration testers' test capability to build a whole series of messages so they could make REST calls automatically. And they virtualized the mainframe. So they now had some end-to-end tests that they could automatically press go on. Every time they did a deployment of an update to the REST services or the SOAP services, they could run all these tests. They were simulating the external providers and the mainframe, and they could very rapidly test changes to where the bulk of the development was, which was in these enterprise SOAP services and REST services. And this really became the core of their regression pack, and they still use this. Finally, the mainframe guys were ready. They came online, but while they were testing all of that, they didn't want to bear the costs of the external provider. Every time they made a call out to the external provider, there was a cost. So they simulated those. They left those virtual services running. They have the same test pack at the front end, so they're now still testing the REST services in the same way, but rather than a simulation of the mainframe services, they're now testing the real mainframe services, and they can check that everything still works. That made a huge difference to them. I won't read through all of these, but as you can see from the top quote, they've now got developers able to see how their changes will react because they can develop a virtual service in 5 minutes as opposed to having to wait up to 5 days for a real developer to code the back end. So it let them get going much more quickly. And the other statistic I'll show at the bottom, which is this idea of availability of services. So this was really how long they had to wait for changes to the mainframe application. Typically, a mobile developer in the past would have had to wait 20 days in order to get that change made, whereas now they could virtualize that, and a day later, the mobile developer could be doing, the mobile tester could be doing some testing of the UI on the mobile app to see how it responds against a virtual service. And that made a huge difference to their overall time to market. It also meant that they were finding far fewer defects later on in the development cycle, which meant that part of the process quickly as well. Another example from the airline world, and this is my last slide, I believe. So they had a different problem, which is that they had shared use of a test environment. So they were building some fairly complicated booking and rescheduling applications, and that had shared use of a reservation and flight control system. And that's fine. So, they had a real environment. This wasn't about an environment not existing. The problem they had was it was very non-deterministic. So lots of teams and lots of other companies were using this test reservation system. And that was a real problem because from a regression test point of view, you couldn't tell what it was going to do. testers would have to run a test and then work out if it had done the right thing based on what data was in the reservation system at that point. And tomorrow, if they ran the test, they might get different results because other people had changed the data. So what they did was a virtual environment, and they do this using our technology to virtualize the services that they could put into a known state every time, so that when they made a change to an application, they could run a series of tests against the virtual services and know exactly how they were going to respond. So from a regression test point of view, they could run this automatically, because if a failure occurred, it was now a genuine failure, not simply because one of the environments they were pulling data from had changed. So this allowed them to build a set of automation tests. It allowed them to get much more reliability into their testing, and the testers have to spend far less time working out if a fault was because the environment had changed or actually because someone had introduced a bug. Clearly, they still moved on to do real testing against the systems, but it let them get to that point. More time testing. These things don't exist in isolation. We're starting to run a little bit short of time, but it's worth saying that all of these capabilities plug into many other tools that typically will be used into a pipeline. So for things like Urban Code and Rational Quality Manager, Jenkins is a tool. All these types of capabilities can be plugged in to automate these tests and automate these virtual services. In summary, a lot of the traditional solutions are really inadequate in the face of what the businesses are doing now. We need new approaches. And although manual testing is a significant proportion of overall software quality, we do need to transition to new approaches to new technology. It's going to be a long journey, but it is an essential one for organizations if they're going to meet the time to market challenge. Thanks very much. I think at that point we'll open to some Q&A.
Marvelous. Thank you so much, Nick. Thank you, Shug and Nick, for a valuable presentation again this afternoon, and for giving us a brief overview of DevOps continuous testing, performance testing, and service virtualization. As Nick did say, we are now taking questions. If you do have any questions, please type in on your individual Q&A pod. We will take a few questions now, and then maybe we'll take a few later on if you do have any questions, further questions. So questions are pouring in. Okay, let's quickly start the Q&A. So first question. You've talked a lot about virtual services. How do you create them? Is it programming? Nick, I think this is yours, sir.
Okay, so it's certainly not programming. And developers have been creating mocks for years, which are code that they write, and they're very hard to maintain. No one really knows how to use them next time around. So no, first of all, they're not programming, because although I've said testers are getting more technical, we're not trying to turn them into developers, and if we program them, we have to maintain them, and it just gets complicated. So there's a few ways to create them. The best way is actually to create them from analyzing real messages. So if systems really exist, then typically what people will do, certainly using our tool, is they'll set the tool up to watch interactions between two systems. So you might watch 1,000 requests for, maybe to do a credit check. And we will then analyze that data, and we will create a virtual service that tries to match that behavior. So it will notice what data in the message is important. It will look at the data that's returned, and it will build a virtual service that actually tries to act like the real service it saw. So it will remember the data. It will remember the inputs that caused particular outputs. And when you start it, it should really do the same thing for information it's seen before. So recording is a good way to do it. Because it allows you to very quickly create one, and you know that it's going to be accurate because you've taken it off real data. Clearly, you can only do that if real systems exist, and there are certainly use cases for that. The other use case is where the system doesn't exist yet, so you're trying to virtualize something that no one's written yet. And clearly, you can't record there because there isn't a real interaction, although you could try and record something close. And this is where you would generally use assets such as WSDL in the web services world, WADL, Swagger files in the REST world, that describe the operations and services. You'd import those into the tool and tell the tool to create a virtual service based on that interface. And that does a lot of the technical wiring. So that allows us to capture messages. It means we understand the structure of the message. And what the tester then has to do is go into the tool and say, when you see this type of request, when you see a request for NICS data, this is the output I want you to give. And typically they're filling in templates. So the tool presents you with a message structure and says, right, what data do you want to type in? And you can then drive that from Excel spreadsheets, you can drive it from databases, but no, it's not programming. You're either watching real systems and we do the work for you, or you're importing assets that describe the interface, such as WSDLs, and then using common tools like a simple UI to type the response in or wiring it up to an Excel spreadsheet so that the virtual service knows what data to respond with.
Thank you, Nick. Just another question following on from the first one. Who should build virtual services? Is it a development task?
That's a good question, and I'm not sure there's a single right answer. Testers should definitely build them. And commonly, obviously everyone's familiar with the idea of exploratory testing. There's also the idea of exploratory virtual services, some of which you'll throw away. So a tester, in my example earlier of the mainframe, a tester might say, okay, I know that this application's calling a KICS transaction. I want to see what happens if that KICS transaction returns a certain exception, and I should very quickly be able to create a virtual service, get it going, return the exception, see what happens, and possibly I then throw it away. Some organisations create centres of excellence, and they have technical testers within there build virtual services for common services. Most organisations will have a whole set of systems that every application uses: authentication, authorization, customer lookup, credit checks, financial data, and then they create centres of excellence that actually build virtual services for the rest of the organisation to use. And when you're building a system, you'll use those to do your initial set of testing. Doesn't always work. Centres of excellence can get a little bit isolated, but that can happen. And we've seen some organisations go as far as saying, actually, yes, developers must build them. And if you as a development team are creating a new system, then actually you have to build a set of virtual services that other teams can use in order to do their testing against a virtual copy of your system. So the answer is probably everyone. They can be used at all sorts of points in the development lifecycle. And certainly you want testers with not too much technical knowledge to be able to use them. But I think the question is more, how can you use them at various points of the lifecycle? And then it becomes, how do we decide whether to keep them for future use or whether we're just going to throw them away? So development testers, predominantly testers, and historically it's been testers, but I think developers are starting to make more use of them as they realise that they are quicker to produce than coding up their own solution.
Great, thank you, Nick. We'll take a couple more questions. Next question. You mentioned using virtual services in performance testing. I don't see how they help there. Nick?
Yeah, it's a good point. And clearly there's no point running a performance test against a virtual service because that's not the thing that's going to be deployed in production. Actually, where they get used here is that typically in a performance test, you're not trying to performance test everything because some things will already exist. And a good example we had last year was a customer who wanted to performance test their internet banking system. So they were in South America. They were launching a new internet banking system with a web UI, and it was hosted on an application server, and actually for all the transactions, it called off to a mainframe. I know I keep using mainframe examples here. They were entirely happy that the mainframe ran fast enough already. But every time they executed a transaction on the mainframe, it increased their MIPS cost, which is the cost they paid for running code on the mainframe. So they didn't really want to execute those transactions for real while they were performance testing their internet banking system, because they were doing tens of thousands of transactions over a long period of time and lots of performance testing. It was going to cost them a lot to run the transactions on the mainframe, which they knew was perfectly capable of meeting the performance requirement. So what they did was create a virtual service for the internet banking system to talk to. and they created a set of services, but equally had to run fast enough. They had to be simple, they had to be running on good enough hardware so that they didn't become the bottleneck, but they allowed them to focus on performance testing, what they were actually trying to performance test, which was the internet banking system, and not running into problems with performance testing the mainframe, which they knew was running quick enough. And equally, we've seen people use them when doing a performance test, finding there's a bottleneck. So they might find one service call is actually running really slowly. They send the development team away to sort that out. But in the meantime, they want performance testing to carry on. They've probably hired a lab. It's probably getting expensive. So they'll create a virtual service to stand in for the thing that was running too slowly. Again, it needs to be simple enough. It needs to be running on good enough hardware so it doesn't become a bottleneck. But assuming you can do that, then you can now carry on performance testing the rest of the application while the developers work out why one bit was running slowly.
Lovely. Thank you, Nick. I'll take another question. So next question. What you have talked about during this webinar what you have talked about during the webinar is a true agile or a hybrid version. Does that make sense, Nick?
It does, and I'd say it doesn't really matter. It probably has more benefit in a true agile because if you want to get the speed that a true agile project delivers, and you want to make decisions on, is this sprint ready for release? Is this a release candidate? Then you need to be able to test very quickly, particularly if you're trying to test in sprint. Which means you need sets of virtual services, you need continuous performance testing, you need integration tests, you need automation to enable you to do that. And I'd say it probably enables more in that type of environment. In a hybrid model where you might be still have a long test cycle, you might be testing in sprints after the development are done, then there's always benefit. There's always benefit with testing earlier and getting to market quicker. So I think it applies equally to both. But I think it probably fits in closer with the true agile model. But really, I think it applies to either. Maybe it's needed more in the true agile model because you need to be able to work more quickly and make decisions about, is a feature ready, is a build integral much more quickly, and it enables you to do that.
Okay, thanks, Nick. Well, I'll take just one more question, Nick. Last question for today. We use HPQC in our integration in our test organization. Can you integrate with the tool, Nick?
Yeah. So an awful lot of people use HPQC for test management, and we've got a number of large customers who actually kick off all their tests from QC, and we have an integration that allows QC to call an integration test in RIT and actually to start virtual services as well. So someone building a whole series of tests in QC, some of which might be manual, some might be UI, some might be calling out to other technologies. We can integrate into Rational Integration Tester, and QC can initiate those tests and get results back. And then testers can decide what they want to do with that. And that's not really just QC. We can do that from Ant, from Jenkins, from Rational Quality Manager, on the command line. So there's a whole ways in which to start and stop virtual services and run integration tests and get results back into other tools. Because, I think I said earlier, typically this is being used in a build and test pipeline. There are a lot of continuous build and continuous testing tools, and we need to make sure that we can integrate into those so that it becomes an automated pipeline and there isn't a manual step where someone has to stop, load Rational Integration Tester, press go a few times, and then see the results. So yes, all of this can be automated using those tools.
Marvelous. That concludes our Q&A session. Before we go, if you do have any further questions, if you would like to ask our presenters, please do email Shug and Nick. Their contact details are on the slide as we speak. The recording will be available early next week. I would hope it would be available by Tuesday, but yes, it will be automatically sent to all attendees today. Without further delay, thank you all very much for participating in today's webinar, and hope to see you once again at our next live webcast.